Okay, y'all listen. Now we're going to move on to finding the coordinates of the missing endpoint. So that means they gave us one endpoint and the midpoint. We've got to find the other endpoint. There's a way to do it algebraically. There's a way to do it just looking at the graph and counting, okay, using slope and counting. So I'm going to show you both ways, and then you can choose which way you prefer, and you can do that from now on. Okay, so the first thing that you should do is plot the points. You're probably going to have to count because for some reason this graph was not nice and didn't print off very nicely. But I have 7, 10. That's going to be my E. I'm going to label it with an E because it's the end point. And then my midpoint is 5, negative 8. And I'm going to label it with an M. Okay, so generally, we can tell if one endpoint is up here, my midpoint is down below it and to the left. The other endpoint, even though it's not on the graph, is below and to the left, right? Generally. Okay? So when we get our final answer, you should be able to look at the final answer and say that's reasonable or it's not reasonable. That should help you with that part at least. So the way that you can do this algebraically is just like how we did it whenever it was a midpoint of a segment, using the two endpoints. Okay? So I use the x coordinate. We have to do it twice because there's an x coordinate and a y coordinate. The x coordinate of the endpoint, the x coordinate of the midpoint. And I would plug it in as 7, because that's the endpoint, plus I don't know the other x coordinate, so plus x, divided by 2 equals the midpoint x coordinate is 5 over 1. Remember, I can put it over 1 because that's not changing the right side at all, but it makes it where now I can actually cross multiply. Okay? This is the same thing, so you don't have to ask me because I know some of you will do this. This is the same thing as working it backwards. So like I was just saying, well, if I know it's 5, can't I just go ahead and multiply that by 2 and subtract that? You're doing the same thing. You're just doing it all without writing it out. Okay? So if I cross multiply, I get 7 plus x equals 10. Subtract the 7, and my x is 3. Because remember, whenever I'm cross multiply here, times 1 doesn't change anything. 2 times 5 is 10. And then you can do the same thing with the y. I'm not going to work all the way through the y because I'm going to show you how you can do it by counting the slope and using that. Okay? So there's 3 steps for that, and it really is only broken down into 3 steps so that I'm not just spewing information at you. The first step, count the slope. It is important this time because I know usually whenever you're taught to count slope, you started at the left side of the graph and then counted how far or how much it took to get to the right side of the graph. For this one, you're going to count slope always from the end point to the midpoint, even if the end point is on the right, which it is in this case. Because the whole idea is, if I had my whole graph, I could count the slope from E to M and then count that again, and that would get me to F, or the other endpoint. Okay? So since we don't have the whole graph, I'm just telling you that you've got to go from endpoint to midpoint every time. So if I counted down from E to M, how far did I have to go down? I went down, so negative 18. Do you agree? 18, because it's 10 down to get to 0. And then 8 down to get to the negative 8.
Oh, my words.
And then how far you're going to the left, which is positive or negative? Negative, how many? 2. Okay, don't simplify it. Don't change it. Don't do anything. Leave it exactly like it is. Remember that on top, since I counted down, that's my y coordinate. And on bottom, since I counted over, that's my x coordinate. Okay? Second step, add the bottom to the x from your midpoint. So what's the x coordinate in my midpoint? 5. Midpoint is 5. So I do 5 plus negative 2 and get 3. Okay. The second part, maybe, is to, or the last part rather, is to add the top to y. What's the y of my midpoint? Negative 8 plus negative 18 gives me negative 26. Okay, again, that's not how I get to leave my answer. What is the midpoint, or the end point, excuse me? Negative 26. So is that to the left and below m? Then we did it right. Okay? So now I want you to try the second one, the second example. I don't care if you do it algebraically or the counting way, whichever way you want to do it. All right? So do that right now and then I'll call on. So, what was the answer? What is F? 9, negative 7. Okay, 9, negative 7 is correct. Just quickly, if you didn't get that for some reason, or if you're just not totally sure, no. The algebraic way for the x coordinate would have been negative 1 plus x divided by 2 equals 4. And for the y would have been 3 plus y divided by 2 equals negative 2. And then counting, what we get for our slope if we counted? Negative 5 over 5. And then we remembered that that was the y. That was the x. Good? Okay, so that's all for the midpoint part. Let's move on to distance. Distance formula is kind of long, but if you look at the back of the very front page, that's the formula chart that you're going to have like on your test. It's going to be there. So you'll have that formula in front of you. So the formula for distance, x2 minus x1 squared plus y2 minus y1 squared. Y2 and y1 can come first. If you want your y's to come first, that's fine. If you want whatever, okay? Or even if you switched them around and you said x1 minus x2, as long as this one is y1 minus y2, okay? The important part that is either that both of the 2's are first or both of the 1's are first. Does that make sense? Okay? So as I go through it, let's do this example. I'm going to label mine. I always just go left to right. It does not really matter. Like left to right on the paper. I don't actually think about which one's further left on the graph if they're just written down. This one happens to be that way, but that's the way I write it. Okay? On this, I'm going to suggest, because on your first example you have to do this part, or on your first activity today you have to do this part. You're going to write out just what goes under the square root sign. We're not going to work through it all the way. I'm not worried about getting a simplified square root, anything like that. I just want to make sure that we're plugging it in correctly. Okay? So my formula says what comes first? X2. So 10 minus, oh, sorry, sorry. Negative 15 minus negative 30. So what can I write instead of minus negative 30? Plus 30. There shouldn't be a negative at all anymore. If it's minus a negative, the negative goes away. Keep, change, or something like that. I don't know. It's one of those. Keep, change, flip is fractions, I think. I don't know. And then what's my second set of parentheses look like? 10 plus 20, because it would be minus negative 20 squared. Okay, so like I said, I'm suggesting you write it here, just this first step, because on your first activity, I'm making you write out your first step. I know you love me. It's okay. You don't have to tell me. But then you can just plug it into your calculator. It's right there. Well, sort of. That was different, so I'll show you. Oh, why did it do that?
I don't like that. I don't like this.
Oh, it's so easy. No, it's easy. I don't put in 555. I'm just doing that so it makes it easier for you to see it on my calculator. If you go to second x squared, second x squared gives you your square root sign. Then type it in exactly like we wrote it down. So with the parentheses and everything. So parentheses, negative 15 plus 30 squared. Use x squared. Don't use the arrow key and a 2. Just use x squared, trust me. Plus 10 plus 20 squared. Does that look just like how we wrote it? Then we hit enter. 33.54.
33.541019.
Because it was minus negative 20. As long as your negatives in parentheses, it will do them correctly. Okay, so my answer is just 33.54. Unless I tell you otherwise, always round to 2 places. That's a good standard for us to keep. Okay, so I want you to try the next example. It's only A and D. You can mark out C and B. It's not that hard.
What do we do? No.
Yes, example 2 is what you're working on right now.
Are we still getting this? No, be quiet.
Yes, you're still looking for distance.
That's right.
You don't have to this time, but I'm going to make you on your assignment in a minute. Not yet.
Not yet.
That's what Caleb said.
Caleb said he's not yet 28.
Right, which one I get people in trouble?
Oh my gosh, like you're putting words in my mouth. No,
What is X and what's Y?
What did we get for the distance? 13.6. Okay, so let me write out the distance in the square root sign and see what you did. Yes, sir. So if the right side was my x2, it would have been 4 minus negative 7, so plus 7 squared plus negative 3 minus 5 squared. Okay, so this was mentioned earlier. You've got to be careful. Your calculator messes up squaring a negative number if it's not in parentheses. So I know as some of you did the parts separately and then put it in your calculator as just -8 squared. If you don't put the -8 in parentheses squared, all your calculator is doing is 8 squared and then throwing a negative in front of it. I don't know why it gets it wrong, but it does. Okay? So questions on finding distance. Okay. We're going to skip the second example too, on the second page for now. But let's just talk about it. If you put the vertices of a triangle, listen. If you put the vertices of a triangle on a graph and you're trying to determine which, if any, sides are congruent, are you looking for distance or midpoint? Distance. And you would find the distance of all three sides. They are not all congruent on this one.
It's the one where it's like two are congruent.
Okay. And you don't have to worry about on that one. You're not going to have to worry about telling me what kind of triangle it is. I'm just worried about which sides would be congruent on that. So you would just be finding the distance or the length of all three sides. Okay. We're going to skip to finding fractional distance. All right, it's really not bad. There's steps. We do have a quiz on this next class, but you do get to use your notes on the quiz. So you get the steps. Okay? So first step, find the slope between the 2 points. Do not simplify. Don't simplify. So if I get 2/4, I'm not changing that to 1/2. I'm leaving it as 2/4. Okay, so do not simplify. The only thing that you will do is you will change the signs if that's necessary. The only reason it would be necessary is if they are both negatives. So if you got -2 over -4, then you would just change it to +2/4. Take the negatives away. Okay? But if one of them's a negative, leave it. Number 2, multiply both parts of the slope by the fraction from the problem. Okay, that should sound similar to how we did fractional distance before. We found the distance first and then we multiplied by the fraction. This one you're just finding slope and then multiplying by the fraction. And both parts of the slope, you're going to multiply the top part by the fraction, the bottom part by the fraction. Okay. Number 3, add the answers from number 2 to the leftmost coordinate value. The leftmost coordinate values. Remember on slope, and I left the slope formula where you can see it up here too, is the top or the bottom the x? Bottom. Bottom is x, which means top is y. And then the last step, which is not even really a step, is just write it as a new coordinate pair. Okay, so what we're looking for here, what we're going to be doing with fractional distance, is you're looking for a point. So on the first example, we're finding a point that's 3/4 of the way between those 2 points. It's always from left to right. You're never going to have to worry about going right to left. Okay, so always from left to right should be not too bad. Okay, so for the first example, we're going to go through all the steps. First step, find the slope. So I suggest labeling. Again, I just go left to right on my piece of paper. I do y2 minus y1 on top, so it's going to be -2 minus 4 on top, And then x2 minus x1 on bottom, negative 6 minus 3 on bottom. What do I get? What's negative 2 minus 4? What's negative 6 minus 3? Negative 9. Do not simplify it to 2/3. The only thing you should do is change your negatives to a positive. Positive 6 over 9. Because all we're doing is we're finding the vertical distance or between the two, the horizontal distance between the two, and then multiplying it by the fraction. And if we reduce it, then we're not actually finding the vertical distance and the horizontal distance. We're just finding the slope. To positives, we changed this because they were both negative to make it into a positive number. That's the only reason.
We just not feel like dealing with negatives?
No, because if one of them, like if it had been negative 6 over positive 9, then I would have left negative 6. But for this one, you're really looking for the absolute value every time because it's distance. So I guess I could have given you that as the answer to the absolute value of it. Second step. What's my second step? What's the fraction in this problem? So I'm going to multiply 6 by 3/4. I'm going to multiply 9 by 3/4. Okay, get it as a decimal, just because that's going to make things easier on you in the long run. So what's 3/4 of 6? 4.5. 3/4 of 9? 6.75. Okay, step 3. Okay, add the answers to the leftmost. Now, this time you actually have to think about which one's further left, 3, 4, or negative 6, negative 2. Negative 6, negative 2, if I graphed both of those points, would be further to the left. Do you agree? Okay, so I'm going to add those coordinates to the numbers that we got. Which one am I going to add to 4.5? Negative 2, because the top one is my y. And what do I get? And which one am I going to add to 6.75? Negative 6, and get 0.75. Is that my answer?
No. Wait.
No. You're right. It's not. How do I write my answer?
0.75.
0.75 comes first because it's the x.
Oh my gosh.
2.5. Okay. Try the second example. Through it. Because then I bet you'll find your mistake real easily.
It's 5/6.
Look. Remember. So on that first step, Christian, on that first step, how am I going to plug in for my slope?
2 plus 3 over 3 plus 2.
2 plus 3 because it's y2 minus y1 on top over 3 plus 2 x2 minus x1. But since my x1 and y1 were both negatives, whenever I do minus a negative, it turns into plus. So what'd you get for your slope?
5/6.
5 over 5. 2 plus 3 and 3 plus 2, so both of those add to 5. Step 2. Caleb, what'd you do for step 2? I multiply by 2/5, which gives me 2 for both of them. Okay, 3, step 3. Chad, what do I do in step 3? Just read off step 3 to me.
Oh, add the answers from number 2 to the leftmost coordinate value.
Okay, so if I look at my 2 coordinate values, -2, -3, and 3, 2, which one's further to the left?
The one that's actually on the left.
The one that's on the left this time because it's the negatives. Remember, I'm going to add the y to the top, the x to the bottom. What's 2 plus -3?
-1,
2 plus -2.
0,
So what's my answer?
0, -1. Wow.
Good?
I've been doing very good.